We're going to look at what's called direct variation. Some xy quantities are in a relation where the ratio of the corresponding values is what's called a constant. A constant remains the same. The formula for direct variation can be written as y equals k times x. So when you have an equation in this form, such as y equals 3x or y equals negative 2x, that is direct variation. Y varies directly with x. That could also be written as, if you would divide each side by x here, that could also be written as y over x is equal to k. And that's the key there. If you divide each y value by the x value, it's going to be equal to what's called a constant of variation, or k. So in simpler terms, for every point in this equation, or on this graph, if you divide y by x, it's going to be the same, no matter which point it is. If you divide y by x, it will be the same. Where k, the constant of variation, would not be equal to 0, because if k was equal to 0, this wouldn't be y equals k times x, it would just be y equals 0. So anyway, direct variation is when it can be written in the form y equals kx. So that's probably the most important thing right there. Direct variation can be written in the form of y equals k times x. Again, examples, y equals 3x, y equals negative 2x, those are examples. It could also be written as y over x is equal to k. So if you divide y by x, it's equal to that constant of variation, which is k. As always, x represents the input values, y represents the output values, and this k is what's called the constant of variation. For each y divided by x, it's going to be the same. It's going to stay constant. The formula y over x is equal to k shows that except for the point 0, 0, the ratio of all output-input pairs equals the constant of variation, k. So here is an example of direct variation. These points represent y varying directly with x. Notice, if you divide y by x, so if you divide 2 by 1, that's going to be 2. Likewise, if you divide 6 by 3, that's also going to be 2. So each time we're dividing y by x, we're getting the same thing. We're getting this constant of variation of 2. 8 divided by 4, if you divide y by x, that is 2. So those set of points is an example of direct variation. That's where y is varying directly with x. It can be written in the form of y equals k times x, where k is the constant of variation. In this case, it'd be 2. So to write it in the form of y equals k times x with k being 2, or the constant of variation being 2, you could write that as y equals 2 times x. So that is direct variation. Again, the key is when you divide y by x, for each point, it's going to be the same. It's going to be equal to that constant of variation. For each function, to determine whether y varies directly with x. If so, what is the constant of variation, and what is the function rule if it is direct variation? So all you have to do here is divide y by x. If it's the same for each set of points, it's going to be direct variation. So if you divide 14 by 2, if you divide y by x right there, 14 divided by 2 is 7. 21 divided by 3 is 7. And 35 divided by 5 is 7. So each time you divide y by x, it is the same, it's 7. That is direct variation. All output-input values, if you divide them, equals the constant of variation, which is 7. So if you divide y by x each time, you're going to get 7. So you could say that y does vary directly with x. And it says, if so, what is the constant of variation? Well, we already know. Each time you divide y by x, it's 7. So the constant of variation is 7. And then finally, what is the function rule? Well, remember, if it's direct variation, if y varies directly with x, it's written in the form of y equals k times x. K is the constant of variation. K is 7. So you could write that as y equals 7 times x, or y equals 7x. That is the function rule. How about this one? If you divide y by x each time on that one, do you get the same thing? If so, y does vary directly with x. So if you divide 22 by 11, 22 divided by 11 is 2. 32 divided by 16, that's again 2. But 42 divided by 7 is no longer 2, it's 6. So there's a problem right there. That means y does not vary directly with x. So if you divide the outputs by the inputs, you're not going to get the same thing each time. So y does not vary directly with x. Therefore, there is no constant of variation, and there is no function rule for this particular one showing that y varies directly with x. It says for each function, determine whether y varies directly with x, and if so, what is the constant of variation? Remember, for y to vary directly with x, it has to be able to be written in the form of y equals k times x. So if you divide each side by 3 to get y by itself, you're going to have y equals, you could think of it as 7x over 3, but that's also the same as 7/3 x. So that is in the form of y equals k times x, where k is the constant of variation. So y does vary directly with x, and the constant of variation here is that 7/3. 7y equals 14x plus 7. So to see if this is direct variation, we want to get y by itself. We want to solve this for y. To solve this for y, you need to move the 7. So to move that 7, divide each side by 7. Now when you divide each side by 7, you're dividing each term by 7. If you do that, get y equals 14x divided by 7 is 2x, and 7 divided by 7 is 1. So y equals 2x plus 1. Now you're asking yourself, is that direct variation? Is that written in the form of y equals k times x and nothing else? So just y equals kx, nothing else involved. Well, that is not, because you have that 1. And if you know slope-intercept form, which we're going to get to later on, slope-intercept form y equals mx plus b, if the y-intercept is something other than 0, where this one had a y-intercept of 0, that is direct variation, but this has a y-intercept of 1. That's not direct variation. So y does not vary directly with x on that one. For y equals x over 9. Can that be written in the form of y equals k times x, like this one is up here? Well, that x over 9, that is the same thing as 1/9 times x. So right there you can see that is in the form of y equals k times x, where k is the constant of variation. So y does vary directly with x on that, and the constant of variation is that 1/9. So if it can be written in the form of y equals k times x with nothing else involved, y does vary directly with x. But if there's something else involved, in other words, in simpler terms, if the y-intercept is something other than 0, these have y-intercepts of 0, but this had a y-intercept of 1. That's where y does not vary directly with x.